Temperature at a point is given by this function. Okay, it's 200 e to the power of negative x squared minus 3y squared. Okay, so that's the temperature. So first, find the rate of change of the temperature at the point 2, 1. Right, so you want to know the directional derivative of this function. Okay, let's just call it f. Right, you want to find the directional derivative of the function, right, at the point 2, 1, sorry, 2, negative 1 along the direction 3. Okay, so what is this direction? Okay, so it is from the point 2, negative 1 to the point 3, negative 3, right? So, this point Q is 3, negative 3, 3. Okay, and from the point P, this point P is 2, negative 1. Okay, so what is this direction? It's PQ, right? Along the vector PQ. So what is a vector PQ? It's just the end vector minus the start vector, right? So it is 3 minus 2, which is 1, and negative 3 minus negative 1, which is negative 2. Okay? So the direction vector, right? So the direction vector v is 1, negative 2, and then we need to get the unit vector of that direction, which is v over its length. Okay, so it's 1, negative 2 over square root of 1 square times negative 2 square. Okay, which is just 1 over 5, 1, negative 2. Okay, then what is a function's gradient vector? So it is a vector of df over dx and df over dy. Okay, so what is df over dx? Just differentiate this by x. So first, e to the power of something, the derivative is itself, and then you differentiate this by x, right? You get negative 2x. And you differentiate it by y, the first part is very similar, then times negative 6y. Okay, times negative 6y. So now you want to know the gradient vector at the point to negative 1. Right, so you just have to do the substitution. It's going to be 200 times e to the power of negative 2 square minus 3 times negative 1 square. Basically, you just have to do the substitution times negative 4. Right? And then it's 200 e to the power of negative 2 square minus 3 negative 1 square times negative 6y, which is 6. Okay, so it is just e to the power of negative 7 times negative 800 and 1,200. Okay, so then for part A, okay, the directional derivative at the point to negative 1 along the direction u, it's just a gradient vector, okay, dot product, the unit vector of the direction. So it's e to the power negative 7, negative 800, 1,200, dot product 1 over 5, 1, negative 2. Okay, so it's 1 over 5 e to the power of negative 7, okay, negative 800 times 1 plus 1200 times negative 2. So the result is negative 3200 over 5 times e to the power of negative 7. Okay. So that is the first part. Okay. Then part B. In which direction does the temperature increase fastest at the point 2, negative 1? Okay, so let's take a close look at the directional derivative. Let's say the directional derivative at any point. Okay, at any point. So what is it? It's going to be the gradient vector at that point, dot product, unit vector of the direction. Okay, then the dot product, it's going to be the length of the first vector times the length of the second vector times the cosine theta, right? It's the angle between these two vectors. So you can see first, the gradient vector at the point, it is a fixed value, right? The gradient vector at the point, it's a fixed value. Okay, we don't know the value, but it's fixed, so it doesn't, right? It won't change the total product. Okay, what about this length of the unit vector? It is 1, right? The length of the unit vector, it is 1. Okay, the length of the unit vector, it is 1. So the only thing that will affect the value of the directional derivative is this cosine theta, right? So when theta, we know cosine theta, the value range of cosine theta is between -1 and 1, right? It's between -1 and 1. So we know when cosine theta is 1, this is maximized, right? So when cosine theta is 1, that means the directional derivative is maximized. Okay, and we know when cosine theta is -1, okay, this directional derivative is minimized. Okay, when will it be 1? Okay, when will cosine theta be 1? That's when theta is 0, okay? When will cosine theta be -1? That's when theta is pi. So when theta is 0, what does that mean? That means these two vectors, the angle between them is 0, okay? Which means u and this gradient vector, okay, when they are parallel, that means the angle between them is 0. That means cosine theta is 1. Okay, so which means if you draw it, so this is going to be u, right? This is going to be the gradient vector. Okay, this is going to be u, this is going to be the gradient vector. So otherwise, okay, this is going to be u and this is going to be the gradient vector, right? If they are in the opposite direction, that means theta is pi. Okay, that means theta is pi. That's when the directional derivative is minimized. Okay, so question 2, it asks, so that this is a derivation. Okay, you don't have to derive it. For part B, you can just apply the conclusion. In which direction does the temperature increase fastest? Okay, so part B, so when u is parallel to this gradient vector, okay, what is a gradient vector? When u is parallel to this gradient vector, sorry, it's not parallel, okay, when u is in the same direction, okay, are in the same direction. Okay, what is this gradient vector? What is this gradient vector? It is, we've already got it. It's e to the power of -7, -800, and 1200. Okay, so remember, u is a unit vector. So all you need to do is use a vector, right, divided by its length. So divided by square root of, okay, negative e to the power -7 square times -800 square plus 1002 square. Okay, you can just do this. So Okay, so when it's along this direction, it is the smallest. Okay, it is the smallest. Let me get the answer. Okay, it's something like this. Okay, it's something like this. Right. Then part C, what is the maximum rate? Okay, what is the maximum rate? So now they are in the same direction, so we can write it down. It's TUF negative 2, 1. Okay, so it's going to be a length of the gradient vector at negative 2, 1 times, right, the length of the unit vector times cosine theta. So now, you know, this part, it's already given, right? It's just the length of this. Okay, it's just the length of this. E to the power of negative 7, negative 800, 1,200. Okay, and times length of u, it's 1, and cosine theta, it's 1. Okay, so you just have to do this part. Okay, this part, if you do it, it's going to be 100 square root of 208 times e to the power of negative 7. Okay, I think this you can further simplify. Okay, it's going to be 1600 square root of 13 times e to the power of negative 7. Wait, I think, no. It's 400, yeah.